Welcome to video 4 of chapter 1, where we are finally going to end our discussion on describing quantitative data. This is where we've been talking about our acronym SOCS for shape, outlier, center, and spread. And what we're going to discuss in this last video on describing quantitative data is how do we know when we talk about center and spread which measures of center go with which measures of spread. Because with center, we said there were three different types of centers. There was mean, median, and mode. And mode really wasn't going to be used very frequently, so I'll just put it in parentheses. But mean versus median. And then for spread, we had three measures of spread. We had range, max minus min. We had IQR, Q3 minus Q1. And we also had standard deviation. So if we're going to talk about maybe mean, then do I get to talk about any of these three measures of spread? Or do I only get to talk about certain measures of spread with certain measures of center? And that is the case. So first, do I use mean or median? How do I know which measure of center to use? And really it boils down to the shape of the distribution. And so if the distribution's shape is skewed, if it's skewed left or right, doesn't matter which direction it's skewed in, then we would recommend using the median. Use the median for your measure of center. Is it wrong to use the mean in a skewed distribution? I mean, could you use the mean in a skewed distribution? You could, but I'm going to show you the downfall of using the mean in a skewed distribution soon. So just know if it is skewed left or right, then a median is the better choice to describe the distribution's center. If the distribution shape is approximately normal, then I would recommend to use the mean. Now, does that mean I can't use the median? No, you could use the median, but I would prefer to use the mean in this case. And last but not least, what if the distribution shape is symmetric, but it's not approximately normal? So which one would I use then? What if it was one of those like bimodal? What if it was roughly symmetric? Does it really matter? Then you really get to use the mean or the median, because if the distribution is symmetric, the mean and the median really should be about the same value. Okay, so now you got a choice here. If it's not approximately normal, but it's still symmetric, you get to choose because both of those values should be roughly the same. All right, so I've got an example here. Here are a set of 20 numbers here that represent Chapter 1 test scores. All right, the median of all these test scores is 79.5, and the mean, X bar, is 79.8. We notice those are really close to each other. They're only 0.3% apart. Now, this is what the histogram looks like, and we'll get into how to create histograms, etc. soon. But if I notice here that the shape of this distribution, if I kind of follow this a little bit here, some people might venture to say, well, that's bimodal. It goes down and then comes back up and then goes down. If you kind of think about connecting the dots to roughly about the middle of the top of each bar here, if you will, you might say, well, that kind of looks like it's bimodal. And I guess you wouldn't be wrong in calling it bimodal. But I would maybe call this approximately normalish. Now, granted, yeah, I did kind of hop over this lower bar here, but it's roughly maybe approximately normal, which is why these two values are about the same. And if you didn't feel comfortable about approximately normal, you could say, well, it's, I don't know, symmetric-ish. So really, I could use either one of these two, mean or median, to describe the center. But now what I want to show you is what happens if I just change two numbers out of these 20. And so what's going to happen is I'm going to change this 78 to a 32. I'm going to make that number a lot lower than what it was before. And I'm going to change this 73 to a 43. So everything else is exactly the same. I've only changed 2 out of 20 numbers. But I want to show you how much effect that has on the mean and the median. So now notice the median decreased by 1. It's now at 78.5. But now notice the mean. It dropped almost 4 percentage points. It's now down to a 76. And just changing those two numbers, look what happened to the shape of the distribution. All of a sudden, we took 2 of those numbers that were probably in the same area of this histogram up here, and we popped them off, and we had to stick them down here on the end of the distribution. Now, the shape of this, we said, could be, I don't know, approximately normal-ish, symmetric-ish. But now, would you say that this distribution is symmetric-ish or approximately normal-ish? And I would say, no, not as much. This, to me, looks more like it is skewed left, maybe. And if a distribution is skewed left, then which measure of center did we say was a better indicator of the true center of the distribution? And that's going to be the median. Okay? So notice that the median in both cases are close to each other, but the mean really got twice the distance, or not twice, almost 4 times the distance away that the median moved away. Now, the reason why this is just the way that the mean is calculated. The mean, if you remember how the mean was calculated, was you had to take all of the values and add them up and then divide by the total number of values. And so if you have some really small values, or on the other end, some really big values, then those will affect the mean because it's a part of the overall calculation. But if you think about how the median's calculated, you just line all of your numbers up from least to greatest, and you just pick the middle number. So that's why the median moved slightly, but not as much as the mean did when we talked about that second new set of data here. Okay? We only moved 2 numbers, so we're still just finding the middle value out of all of these. So these 2 numbers had a very small effect on the median switching, or becoming lower in this case. So the mean is what we're going to call, it's less resistant to the effects of extreme values, or those extreme values may be considered outliers, than the median. Okay, the mean is less resistant. It can't resist the effects of really, really small or really, really big numbers in a set of data. So if the shape is skewed, then the mean will always be pulled towards the tail of the distribution and become less reliable as the measure of center. So again, when we go back and look at this here, we added some smaller values, and that started creating this tail on the left side. So the mean starts to become smaller. If I can make this look more like an arrow here. There we go. We'll just do a big solid arrow. The mean all of a sudden becomes smaller and starts following this tail, if you will. Meanwhile, the median's still back here. It did move a little bit, but again, not as much as the mean. So again, if the shape is skewed, the mean will always be pulled towards the tail of the distribution. So I just showed you a skewed left example. There could be an example of where all of a sudden you've got a skewed right distribution, and then the mean will be greater than the median. So in this case, the mean, x bar, is less than the median. Again, if I had a skewed right distribution like this, then the mean would be greater than the median, because the mean is going to get pulled towards this tail, leaving the median behind. So if that was the median, then maybe here's where the mean is located. And I'll show you an example of that upcoming. So here's 2 distributions, one of which is approximately normalish. I'd say this taller one is roughly approximately normal, and its mode is really the peak of the distribution here, but it's not exactly approximately normal. If it was exactly approximately normal, the mode, the median, and the mean would all be right on top of each other. And we can see that they're slightly separated out here. But notice the median and the mean, the green and the blue here, hopefully you're not colorblind, you can notice that they're really, really close to each other. And again, and that's because of the shape of the distribution. It's almost approximately normal. But if we look at this other distribution down here, this one that is very strongly skewed right, then here's where the mode is. It's where the peak is. But the mean and the median, you kind of notice here's where the median is. It's really at the same location as the other approximately normal distribution, but the mean has been pulled way down here towards the tail end of the distribution. So even though the mean versus the median, notice here in both of these cases the mean is greater than the median, but the mean is much greater than the median in the distribution that is more skewed. Okay, so you might say, hey, this distribution is very, very slightly skewed right, I guess you would say. But would you call this distribution skewed right? And I wouldn't. I would call it more approximately normal. But technically, since the mean is greater than the median, there is a very, very slight measure of skewness here, skewed right. But since you can tell that the mean versus median in this one has a much larger gap, then you definitely know that this distribution must be skewed right, because the mean is far greater than the median. All right, so to end up this video here, we now need to talk about, if we're going to use the mean, if it's an approximate normal distribution, then which measure of spread do we really get to use with the mean? And so if we're going to use the mean, standard deviation is going to be the measure of spread that you're going to use with the mean. Think of mean and standard deviation like peanut butter and jelly. They just go well together. Okay? So anytime you refer to the mean as the measure of center, you should be using the standard deviation as your measure of spread. Now, is it wrong to use mean with IQR? Not exactly, but this is just a much better fit, mean and standard deviation. If I was going to use median, then which measure of spread do I use? Well, we're probably not going to use standard deviation, right? But which of range or IQR do we use? It really kind of depends. If there are no outliers present, you could use range. If there are outliers present, I would definitely use IQR. Now, if you really, really wanted to, you could always just use IQR with median. But sometimes you might have a set of data that you don't know easily, let's say, what Q1 and Q3 are. And it's going to be kind of a pain to calculate what Q1 and Q3 are to calculate the IQR. So if you've got a set of data, or maybe you don't have the data, and you can't pinpoint where Q1 and Q3 are, then it's acceptable to go ahead and just use the range, because that's just max minus min. And those should be easier numbers to figure out. So I would say for the most part, you're going to use IQR with median, but range is still viable, especially if there's no outliers present. All right, so overall now, we've been talking about describing a distribution with SOCS, and now we're going to put it all together. So if I said describe the distribution of the textbooks currently in the backpack, first of all, we would start with our shape. And people would say, hey, this is skewed left, because there's the tail end of the distribution. But then I would say, trick question. We can't describe the distribution of the textbooks currently in the backpack, because we can only describe the distribution of a quantitative set of data. And this isn't quantitative, this is categorical. Who says that math has to be the thing that's on the far right? Well, what if I put math down here on the far left in this categorical relationship? Now it looks more skewed right? Or what if I put math right in the middle here? I kind of spread these out. Maybe I switch science with Spanish. Then you might say, well, now it kind of looks more bell-shaped. Maybe it's slightly skewed left at this point. So this is why it's really important that you only describe distributions of quantitative data sets. You can't do it with categorical, because really with these categories, I could switch this math around anywhere I wanted to, and now all of a sudden, amazingly, it takes on a different shape. So you can't describe the shape of a categorical set of data. It's just not possible. So let's change this ever so slightly. Let's change the textbooks that are in the backpack to the number of books. So who cares how many math or science or Spanish textbooks there are in the book bag? Let's just talk about the number of books. That is quantitative. So now, whenever we're asked to describe the distribution, we have to comment on the SOCS. And really, do you have to go in an SOCS order? No, you don't have to, but typically that's kind of the way you might go. And out of the SOCS, I would maybe, just maybe, put the O at the very end. And maybe talk about the shape, the center with the spread, because those are the three really most important things to discuss. And then we could talk about if there are outliers present. Okay? So first let's start with shape. And now this shape truly is skewed left. So I would first start off by saying, let's grab blue here for instance. If I was to ask to describe the distribution, I would say the distribution, and I'll do some abbreviating in here, the distribution of what? Of the number of books. I got to describe exactly context here, what the distribution I'm describing is of of the number of books, I'll skip over in backpacks just for time's sake here, is skewed left. And I could even probably throw in there a strongly skewed left if I really wanted to, but skewed left is good enough. So it's skewed left with a center of. Now, if I said a center of, then I got to remember, do I get to use a mean or a median with a skewed distribution? So I'm not actually going to write out center. I'm going to specify which measure of center I'm going to be using. And we said earlier that if the distribution is skewed left or right, we're going to use the median to describe the center. So if I were to put all this data into a list, and this is saying that I have 1 0 and I have 2 1s, so notice I've got 2 1s in here, and there are 2 backpacks that have 2 books each, so I've got 2 2s, and then you start to lose all the other numbers I've got here, but there should be 5 3s, and you can only see 2, but there's 3 more underneath this, and then there's a lot of 4s, and so there would be all those 4s. There would be a 4 for each one of those dots that are in this list. And then I did some one variable statistics like I did back in video 2. So in all of this, here's the median, 3.5. So again, I'm not going to say with a center of 3.5, because if I say a center of 3.5, then am I talking mean or median? And you might say, well, it's obvious, it's the median here. The mean is 3.05. True, but the person that is reading this may not see all of this information here. So how do they know if you're talking mean or median? So just be specific. So with a median of 3.5 and I'm not going to use the word spread because now I need to specify which measure of spread. Do I use range or do I use IQR? We said it kind of depended on if there were any outliers present. So before I can really finish which measure of spread I can use, we need to determine if there are any outliers. So back from video 3, we talked about the 1.5 IQR rule. And so that was based on taking 1.5 IQRs, taking that value and subtracting it away from Q1, but then adding it onto Q3. And if we had any numbers that were smaller than that Q1 minus 1.5 IQR, then that was an outlier. Or if we had any numbers that were bigger than Q3 plus 1.5 IQRs. So let's take a look at our statistics down here. So Q3 has a value of 4, which coincidentally is the max value. So don't think that Q1, Q3, the median, the min, and the max, that they all have to be different numbers. They could be the same potentially. So Q3 is 4, Q1 is 2.5. So what's the IQR worth? 4 minus 2.5, and IQR is worth 1.5. So 1.5 times an IQR of 1.5 is 2.25. So we're going to subtract 2.25 from Q1, and Q1 was 2.5. So let's throw this over here now. So if I had Q1 minus 2.25, and Q1 was 2.5, so 2.5 minus 2.25 leaves us with a quarter, 0.25. Do I have any numbers that are smaller than 0.25? And I do, 0. So 0 is an outlier. So I know 0 is an outlier. Well, now let's check on the other end of the distribution. If I had Q3 and I added my 1.5 IQR, that 2.25 number, Q3 was 4, and I'm going to add 2.25 onto it. So do I have any numbers that are bigger than 6.25? And that would be a big no because my maximum was 4. So I don't have any upper outliers, but I do have one lower outlier. So if I have an outlier present, then we said IQR was the better measure of spread. So now to finish off my statement here, I've got a median of 3.5 and an IQR of not 2.25. That's how much 1.5 IQRs were worth, right? So I've got an IQR that was worth 1.5 and an IQR of 1.5. Now I can talk about my outlier, for instance, here. So we have one outlier at 0. Now, if I had more than one outlier, then I would just name all of those particular outliers. So now, anytime you are asked to describe a distribution of a quantitative set of data, I'm going to be expecting sentences. Sentences in a math class? What is going on here? Yeah, I'm going to expect you to write out like 2 sentences like I did here. What happens if there are no outliers? Then you can just say down here, there are no outliers present. But you still have to show me the math that proves that there are no outliers. Again, if you wanted to switch up the shape, the center, the spread, and kind of mix these around, hey, that's fine. That is completely fine, guys. I could care less if you mix up the order. But make sure that you're using the correct measure of center. In this case, we had to use median, and we used IQR since there was an outlier present. So there are some rules that you're going to have to kind of keep straightened out in your head here. Some things go better with others. So now what I want you guys to do is do the same thing that we just did together. I want you to describe the distribution of the flights of stairs climbed per day. We've got a minimum of 0 with a maximum of 8. We've got a bunch of values in between. So again, tell me the shape, tell me the center, tell me the spread, and also check, are there any outliers present? And we will discuss this the next day in class. And that is all for video 4.